All right, so in this video, we're going to be talking about finding derivatives. So the first thing I want you to do is I want you to pause the video, go to the quick review on page 801, and do 1 through 10. So go ahead and try that quick review, and then once you play the video, I'm just going to pop up all of my answers and kind of talk through them. So our first two, remember our slope equation is y2 minus y1 over x2 minus x1. Okay, so I label my points first so that I don't mess up which one is y2, which one is y1, and so forth. Okay, and then I go ahead and shove it in. So y2 minus y1 over my x2 minus x1 to get my slopes. So finding the actual equations. So here's the deal. We have two equations. We have y equals mx plus b. We also have our point slope formula. The easiest one to plug into is the point slope formula, which you guys should have watched the video on that formula. Okay, so the first one I went into y equals mx plus b. I could have gone straight into my point slope formula. Okay, if I went to that, it would be y minus y1 is equal to slope x minus x1. Those two negatives would make them a positive 2. Okay, all the rest of them I did point slope form because it was easier. So in question number 4, I had to find the slope first. So there's me finding the slope. And then I took the original point. I chose 1, 6. You could have chose 4, negative 1. It technically is the exact same answer. Okay, and then I went into my point slope form. Sorry, the 3 in the bottom looks weird. Okay, number 5, parallel means the same slope. So I just took that slope and I am reusing it. And then I went into my point slope formula. And then my last one here is perpendicular. Perpendicular lines are opposite reciprocals, the double flip. So here is my new slope based on having to do the opposite reciprocal of this. And then I went into my point slope formula. Okay, so my next set here, we needed to simplify the expression. So the first thing I did was I saw that squared, I wrote it out twice, I distributed, then I took that and I shoved it back in. I still had that minus 4 left. I combined like terms to get to this point. Okay, and then I saw, okay, well, I have an h that I can take out of the top. I took it out of the top, which since then it's in multiplication mode, I can cancel it with the bottom. Question 8, I did the same thing. I took that squared, I wrote it out twice and distributed, combined like terms in the top, took that HGCF out and canceled it at the bottom. And the next one, I needed to get common denominators. So I multiplied the left one by 2 over 2 and the right one by 2 plus h over 2 plus h. I did 2 times 1 to get 2 here. This, I distributed this. So negative 1 times 2 gave me negative 2. Negative 1 times h gave me negative h. I could then, since now we have common denominators, bring them together. So 2 plus negative 2 got my negative 2's to cancel. That is how I ended up with the negative h on top. This is my big division bar. So I'm going to multiply by his reciprocal. So I put that bottom guy over 1 so that I could actually do the reciprocal of it. Then I could cancel my h's. Same thing on top, same thing on bottom. They went ahead and went away to simplify my answer. So the next one is pretty similar, except for it had x's in it and not a 2. So first step, I bumped my negative up again. Got common denominators. I distributed that negative 1 to the top right. Combined like terms. So I got my negative h left. I found my big division bar, and then I multiplied by his reciprocal. And then cancel those h's again. It's the same thing on top, same thing on bottom, and we're in multiplication mode. Okay. So, derivative of the points. We have f of x minus f of a all over x minus a. Derivative is kind of like that change of direction. So we're finding the value of the changing of direction. We talk about it a lot with velocity. Okay. So this is the general definition of a derivative of points. This is the one we're going to be using a lot from here on out. So if we are going to a specific point, that's set A. Or if we're just doing a general derivative equation where we're trying to find x, where we're just going to have that general x sitting in there. So similar equations, one just at a specific point. The other one is our general derivative for x. Notice all of them have h approaching 0. So we're going to have to simplify because right now I couldn't type 0 into this whole mess because I would get an error in my calculator. Okay. So the first one we're going to do is at the specific points. So if I go back and I grab this equation here, we're just going to write the equation out first and then I'll kind of fill in. H. All right, so this represented kind of that f of x. Okay, so I'm going to take this and plug this in. Notice these are the same. I'm going to plug it in for that x value here. So anytime I see an x, I'm going to replace it with a plus h. Okay, and that a, I'm going to do the same thing. So let's go ahead and fill in our 4 for all those a's so I can actually see what I'm doing here and what formula I'm going to be plugging in. So I'm going to plug in 4 plus h in for those x's. This stands for f of x. This stands for f of a, okay, in our general points. So I'm going to be plugging them in for those x values. All right, so I'm going to plug this in. So I'm going to take out that variable and I'm going to shove in 4 plus h using parentheses if they don't have any. And then I'm also going to shove it in here. So 2 times 4 squared minus 3. Yeah, all over h. Now we simplify. So this, I'm going to do it over here actually. So 2 times 4 plus h. Write it out twice. We leave the 2 out there and we work this set first. So that gives me 16 plus 8h plus h squared. Then I can send my 2. Okay, I'm going to go up and replace that one spot right there. If I can fit it in. H 0. So I'm going to replace this with 32 plus 16h plus 2h squared. I'm going to go ahead and type this in here. That gives me 29. Left off something in this equation. Oh, there's a minus 3. Shoot. There should be a minus 3 in here because it was 2x squared minus 3. So there's still another minus 3. My apologies. Okay, because these will then end up canceling each other out. So we'll get f prime of 4, limit, h approaches 0, 16h plus 2h squared all divided by h. I still can't type this in because that h in the bottom. So I'm going to take that GCF out of the top. I'm not actually going to take a 2 out. I'm going to leave it in there. I'm only going to worry about trying to get rid of that bottom part. So I'm going to take the h out so that I can cancel it. So I have 16 plus 2h. Now I can plug that 0 in. So if I plug that 0 in, f prime of 4 as the limit, h approaches 0. If I plug it in, it is going to give me 16. 16 plus 2 times 0, 16. So that is going to be the slope of that tangent line at that specific spot. Okay, so if for some reason then you needed to go into point slope formula, that would be the slope that you would use. So you would do y minus y1 equals m, x minus x1. Okay, so that would be your slope. Your point then, you had 4 as your x value, your y value. Technically, when we plugged it in, we got negative 29. Okay, this isn't in this worked out example, but just saying if you had to find the actual equation, there's your slope. Your x value was 4. You got negative 29 in response. If you needed to get to the point where you're actually finding the equation of that tangent line, that's kind of the route that you would take to get to it. Okay, so page 801, use the graph to find the slope of the tangent line if it does exist. Okay, so see if you can figure this one out. Give yourself a couple minutes here. All right, so it was to estimate the slope because we don't have an equation. I can't actually do the derivative. So at x is equal to 0, what you're actually going to just kind of do is do the slope of 2 different points. Since we're just estimating, that's going to be more of a secant slope because secant lines, remember, aren't tangent lines just touch. Secant lines kind of actually go through the actual spot. So it's not going to be a full true answer to what the tangent line is. But if you do the general slope of this, so pick 2 points, do y2 minus y1 over x2 minus x1, you'll get your estimated secant slope, which is a closed slope. So this one, if you did it, you would get x is equal to 1. All right, find the derivatives of the function. So f of x is equal to x squared. So I'm going to go back to this equation. We're using our general derivative equation. So I'm going to go ahead and write that down again. Alright, so that stood for f of x. I'm going to take this, plug it in, take that, plug it in, and that's going to represent that two spots. So f prime of x is equal to limit as h approaches 0. I'm going to plug x plus h in with parentheses, and then I'm going to plug x in. I don't really need parentheses around that one. If you want to put parentheses around it, you're more than welcome to. Okay, that square tells me I would technically write him out twice. Oops, that was supposed to be a minus sign. Right here. Minus. There we go. Okay, so then if I distributed, I would get x squared plus 2xh plus h squared. So I'm going to fill that in. Notice how I am writing this long process every single time so that I know that I am still talking about finding a derivative. Don't cheat the system and just write the answer in. Okay? So those cancel. I notice I can pull that HGCF out again. So I would get 2x plus h left. I could cancel them. Okay, so I would have 2x plus h, where if I actually plugged it in, I would get 2x. So that is the equation of the tangent line that would be the derivative to 1 over x squared. And the next one we're going to find is 1 over x. So this is also still in the book. Okay, when we're doing it, I'm using the exact same equation. So f prime of x is equal to the limit as h approaches 0, f of x plus h minus f of x all over h. I plug that in for x, I plug that in for x, and then we will rewrite. So f prime of x is equal to the limit as h approaches 0, plug x plus h in. Plug x in. Okay, this is why we practice this in the quick review. I have to get common denominators. I'm going to bump that negative up first. Times him by x. Times him by x plus h. Okay, so 1 times x gives me x. Negative 1x minus h. I can bring them together because now they have a common denominator. X plus negative x cancels, so I'm going to have negative h over. Hopefully, we start to see the shortcut with this guy on how we would write our answers so we don't have to keep doing it. Here is my big division. I'm going to put it over 1, multiply by his reciprocal. Those h's are going to end up canceling. So I've got negative 1 over x times x plus h. Now if I actually plug 0 in, I basically get negative 1 over x squared as his derivative equation. Okay, so we're going to find the derivative of this one. So this one, we've done 2 of them now. Pause the video and see if you can do it on your own to see kind of if you're able to do it. So go ahead and pause the video and try this one on your own. Okay, I am going to just kind of play out the work here. So I'm going to pause this and then I'm going to write it all. All right, so for this one, I plugged in my x plus h into that x squared. I plugged in my x into that x squared. Okay, so that is my middle guy right here, me plugging them in. I took this one over here, I wrote it out twice, set my negative 3 in. Okay, that 2 was still sitting out here. That was that whole mess that I just found. Okay, this, I distributed the negative 1 to get negative 2 plus 3x squared. I started to combine my like terms. So went ahead and canceled out the 2 minus 2, canceled out the negative 3x squared and positive 3x squared. to get my negative 6xh minus 3h squared left. Took out that h on the top, so I cancel it with the bottom. Okay, this last step, I plug 0 in for this h, so negative 6x minus 3 times 0 gives me negative 6x left as the derivative equation.